Okay, so what we need to do here is solve for the variable theta. So what we do first is isolate the trig function and then take it from there. So when I say isolate, I mean we want to solve this first one for sine theta. So that means I got to get rid of the 2 and then the other 2, the squared. So what I'll do is divide by 2, and that leaves me with sine squared theta equals 1/2. And then we take square root both sides. And remember, whenever you take square roots when solving, you got to do plus or minus. And that gives me sine theta equals plus or minus the square root of 1/2, which is square root of 1 is 1, plus or minus 1 over root 2. And if you rationalize that, you should get a familiar value for your sine function. Okay, so sine for sine output. Sine theta equals plus or minus root 2 over 2. So now you need to figure out where that happens between 0 and 2 pi. So you should know, and this is how I usually explain this in a pre-calculus class. I go to quadrant 1. There's one answer, pi over 4, because I know the sine of pi over 4 is root 2 over 2. But I have to get all the places that happens between 0 and 2 pi. So here's the pi over 4, but that also happens again here, this angle with reference angle pi over 4, right? Sine's positive there. Those are my 2 positive answers. So that's actually should be 3 pi over 4, right? That's 3/4 of the way to pi. So that's pi over 4, 3 pi over 4. And then because of this negative sign, it happens down here, reference angle pi over 4. So that's this angle, that's one answer. So that's pi, that's half a turn, plus pi over 4, which is 5 pi over 4. And then you have one more answer here, where sine's negative here, reference angle pi over 4. And that angle should be 2 pi would be a whole revolution minus pi over 4, or you recognize the angle from your unit circle as 7 pi over 4. So that is my answer set. Okay, so the next one, I can't really isolate one trig function. So this is one of the methods we have for solving these things is to factor. Right, so you have a secant and cosecant, right? So that's sort of a problem. You can't really you can't use identities and come up with just one trig function. That would be one approach. Another approach would be to try and separate them by factoring. So I'm going to subtract the 2 cosecant theta from the right. So now it's equal to 0. And now we're going to use our old zero product principle. I have a common factor, cosecant theta, factor that out. So he's factored out secant theta minus 2, and the zero product principle goes like this, right? If I have a product equal to 0, then either part of that product can be 0 and give me a solution. So I have to know when the secant of theta equals 2, or when the cosecant of theta equals 0. Okay, so let's start with the cosecant. So remember, usually when I have cosecant or secant, I want to just change it to the ones I'm more familiar with, sine and cosine. So let's put this over some number, I don't know, r. Cosecant of theta is 0. So that means the sine of theta would be the reciprocal of that. So that's why I gave it a denominator. And the reciprocal would be r over 0. In other words, if the cosecant of theta is 0, the sine of theta is not defined. In other words, that equation yields no solutions. Okay, so we don't have any answers from that one. So we don't have to worry about that guy. But this one should give us a couple answers. The reciprocal of the secant function is the cosine function. So I reciprocate the 2, and now I have to figure out where the cosine of theta is 1/2. That happens in quadrant 1. In quadrant 4, right? All students take calculus. That's where stuff's positive. Everything's positive in quadrant 1. Sine positive quadrant 2. tangent positive in quadrant 3, the other 2 would be negative, right? That is, sine is negative and cosine is negative. And then just cosine positive in quadrant 4. So that means this answer should be the angle, right? The cosine of what angle in quadrant 1 it gives you a half. Well, that should be, your choices are 30 and 60, right? And that should be your 60-degree angle. And then, of course, your 60-degree angle here in quadrant 4. So that'd be 2 pi minus pi over 3, which is 5 pi over 3. That's my second answer. And then, of course, the guy in quadrant 1, which is just pi over 3.